All right, today what we're going to do is learn how to talk about stuff in standard form. We're going to be able to identify a bunch of characteristics of the graph of a linear equation if it's written in standard form. So to review what we've been able to do so far, we've been able to find slope given 2 points. We've been able to write equations in slope-intercept form. We've been able to determine some characteristics of equations in slope-intercept form, and we've been able to make equations look like they're in standard form. And so now what we're going to do is learn how to tell some characteristics of standard form. But first let me highlight some of the review that we talked about. So from slope-intercept form, we remember y equals mx plus b, and we were able to tell some information from this where the m was the slope and the b was the y-intercept, that point on the graph where the graph intercepts the y-axis. And that's pretty much all we could tell from slope-intercept form. Well, what could we tell from standard form? That's going to be what we're going to talk about today. What is it that we can tell from standard form? Can we tell some information given an equation like this? Can we find out what the slope is, what the x-intercept and y-intercept of the graph would be just by looking at the equation? Of course, the answer is yes. Now, there are 2 different ways that we could tell slope. There's the long way and the fast way. All right, so first of all, we have our equation, 2x minus 5y equals negative 20. Now, first of all, what you can't say is that, well, the slope is 2, right? You can't say slope is 2 because some people will think that the slope is 2 by looking at this equation. Well, they're getting confused because they're thinking about slope-intercept form where the m was the slope. Well, guess what? This is not slope-intercept form, so you can't do that. You can't say the slope is 2. What you can do, if you choose, is solve this equation for y. Make it look like it's in slope-intercept form, and then you can tell the slope. That's one of the ways that you can do it. Okay, so if we're going to find slope with that equation, what we have to do is make it look like slope-intercept form. And the way we put this in slope-intercept form is to get y by itself. We're going to solve for y. So the first thing we do is undo the 2x on both sides. And when we undo the 2x from both sides, we have negative 5y equals negative 2x and then plus 20. And this is just like what we did in the previous lesson about writing equations into slope-intercept form. And then what we can do is divide both sides by negative 5. Remember, multiplication is distributive, so we would be able to divide everything by negative 5. And then we would have y equals, and now we have positive 2/5 x, and then minus 4. Now that this original equation is in slope-intercept form, remember what we said, we couldn't say that the slope was 2. Now it's glaringly obvious that we couldn't have said that because the slope most definitely is 2 over 5. Not 2, 2 over 5. So that's the long way that you can tell slope from standard form. Okay, the long way that you can tell slope from standard form. You can make that equation look like slope-intercept form, identify the slope. Now the short way, remember standard form looks like ax plus by equals c. Notice what we had to do in the previous equation. What we had to do was undo the 2x from both sides and then divide by what was in front of y. So we could undo the ax from both sides and divide by b. And so you can tell slope from standard form is when we undo a and divide by b. So the slope from standard form, opposite a over b. Here's how this would look in the equation that we have. Our a, or the number in front of the x, is 2. To find slope, it would be opposite, so we'd have opposite 2, and that will be over b, the number in front of the y. And the number in front of the y is negative 5, not just 5, but negative 5. So opposite a over b negative 2 over negative 5. A negative over a negative is a positive, so the slope will be positive 2/5. And that is the slope of this, and that's the fast way of finding slope from standard form. Okay, so once again, we still couldn't say it was 2. We could say it was 2/5. So you can look at an equation in standard form, use opposite A over B, or you can do all of the work to put it into slope-intercept form. All right. So now, what about the x-intercept and the y-intercept? Well, we have to remember, what does x-intercept mean? What does y-intercept mean? And in order to do that, we have to think of a graph. Okay, so you think of a coordinate plane, and you think about a graph. We have the x-axis here and the y-axis here. What intercept means, okay, when we look at the question, what intercept means is the point at where it crosses. Okay, so the intercept, the x-intercept, is that point at where a line crosses. This is the definition of x-intercept. So any x-intercept along this line, well, is the x-intercept. Any ordered pair on this line is the x-intercept. Likewise, any ordered pair on this axis, any ordered pair on this axis is the y-intercept. And that's just what it is. So now we understand that this is what the x-intercept is, any point that intercepts this axis. This is what the y-intercept is, any point that intercepts that axis. Now we have to look at the ordered pairs, and you'll see something interesting. The x-intercept, this ordered pair right here is the x-intercept. Notice what the ordered pair is. It's 3, 0. This y-intercept, this ordered pair that intercepts the y-axis, this ordered pair, this y-intercept is 0, -3. Okay, so notice the ordered pair for here is 0, -3. The ordered pair for here is 3, 0. What's going on with these intercepts and 0? So notice, the x-intercept is when the y-coordinate is 0. And the y-coordinate is when the x-coordinate is 0. So the y-intercept is when the x-coordinate is 0. The x-intercept is when the y-coordinate is 0. That is by definition what those intercepts are. Okay, so we have to know these definitions of what a y-intercept is and a definition of what the x-intercept is, and that will help us greatly when we're looking at an equation in standard form to identify those pieces of information. So here's our equation in standard form. So we have 2x minus 5y equals -20. Now, the x-intercept, to find the x-intercept, we use the definition. The x-intercept is when y equals 0. So what we're going to do is make y 0. We're going to play the what-if game. What if in that equation y was 0? We have 2x minus 5y, and that will equal -20. And what we're going to do is find out, well, what would x be if y was 0? Right? It's that if-then relationship of ordered pairs. So we multiply 5 times 0 is 0, and we'll be left with 2x equals -20. 5 times 0 is 0, so it's gone. Now we solve for x. When we solve for x, we divide both sides by 2, and we find out that x equals -10. So when y equals 0, x is -10. Make that an ordered pair. The x-coordinate is -10 when y-coordinate is 0. That is the ordered pair for the x-intercept. Okay? Now, the y-intercept. So the y-intercept is when x is 0. And so we're going to play the what-if game here. What if in this equation x was 0? So we're going to play the what-if game. What if x was 0? So we have 2x minus 5y equals -20. And then we're going to find out, well, what would y be? If x is 0, what is y? So we crunch some numbers. 2 times 0 is 0. That leaves us with -5y equals -20. And we solve for y by dividing by -5. And so we find y to equal +4. So when x is 0, y is +4. That is our y-intercept. And so we write that ordered pair. When x is 0, y is +4, we write our ordered pair. So our x-intercept is -10, 0. Our y-intercept is 0, +4. And remembering that our slope was opposite a over b, or +2/5. And we can tell all of that information just by looking at an equation in standard form. So it turns out standard form can be useful, but you cannot confuse this with slope-intercept form. Thank you.